All right, this is going to be our last section for chapter 8 about area, and this is going to be related to area and similar figures. So let's do an investigation and see how the area and the perimeter change when you dilate these figures. So in step 1, it says draw a rectangle on a circle, label the measures of any size. Okay, so let's keep it real simple. So we're going to draw a rectangle. I'm going to use my little cheat tools here. I'm going to draw a rectangle here, and then I'm going to draw a circle over here. Let's talk about the measures here. Let's just say this is 2 and this is 4. And then we'll say this radius over here, let's make it 3. Okay. So then it says calculate the perimeter or the circumference and the area of these shapes. Okay, so for perimeter, this is going to be simple. This is 4, this is 2. So the perimeter is going to be 12 units. Over here, the circumference is going to be 2 pi r, or pi times diameter, which would be 6 pi. Okay, and this is in units because we didn't have any measures here. All right, now find the area. Area of this one's going to be 8 square units. The area of this one is going to be pi r squared. So r squared, 3 squared is 9. So our area is going to be 9 pi units squared. Okay, so now it says dilate the scale factor of 2. And now find your perimeter and your area of your new figure. Okay, so we want to draw a little bit bigger figure. So I'm going to just make this 2 times bigger. Maybe not drawn to scale, but just we're going to label it to be 2 times bigger. All right. So then we have some new measures here. So my new measures are going to be 4 and 8 because it says to dilate it by a scale factor of 2. Over here, our new radius is going to be 6. And now it says find your perimeter and your area of your new figure. Okay, so this is going to be 8, not 4. This is 4. And perimeter of this one is going to be 8 times 3, which is 24 units. And then for the area, it's going to be 8 times 4, which is 32 square units. All right, let's look at this one over here. The circumference for this one is going to be pi times diameter, and the diameter is 12. So it is 12 pi units. The area is going to be pi r squared, which is 36 pi square units. 36 pi squared units. Okay, did that. Okay, then it says dilate the circle by a scale factor of 3. Find the circumference and the area. And then on the other one, it says dilate one of the original figures by 5. So we're just going to kind of continue this one more time. So if I need to make this 3 times bigger now, okay, so I'm going to get the original one. And now it's going to be 3 times bigger. Okay, again, just drawn to scale. So this radius, since it's 3 times bigger, is going to be 9. And this is the one that is 3 times bigger. So the circumference here is going to be 18 pi, pi times diameter. The area is going to be pi r squared, which is 81 pi units squared. Let's do the next, go back and do the rectangle, and this time let's make it 5 times bigger. So I'm not going to make it really 5 times bigger. I'm just going to draw a bigger rectangle, and maybe not even that big. and I'm going to label it. So if I'm making it 5 times bigger, that means this is now 10 and this is 20, because 2 times 5 is 10 and 4 times 5 is 20. So our perimeter is now going to be 20 times 3 is 60 units, and our area is going to be 200 square units. All right, so now it's just talking about, now let's start comparing these new areas and these new perimeters with your scale factor. Okay, so remember our scale factor for this one here was, our scale factor was 2. Okay, if you notice, I'm going to highlight the perimeter of our new one got 2 times bigger. So the perimeter has the same exact scale factor of 2. However, this area did not get 2 times bigger. Okay, the area, which is in units squared, got 4 times larger. Okay, so like your area scale factor, so to speak, is not 2 anymore. So for the area scale factor is 4. Okay, so let's talk about that here in a second. Let's look at over here with the circles. Our scale factor here for this one was 2. Okay, and as I look at the perimeter or circumference, it's 12 pi. The original was 6 pi. That one also got 2 times bigger. However, the area did not get 2 times bigger. Okay, so this area right here got 4 times bigger. So I'm gonna kind of write that down. The scale factor again for the area is 4, not 2. And then as we look at the scale factor of 3, so our scale factor over here was 3, the circumference got 3 times bigger compared to the original one right here. Okay, however, the area did not get 3 times bigger. It got how many times bigger? It got 9 times bigger. So your area scale factor for the areas was 9. So scale factor was 9 for that area right there. And so those are some things that you have to notice. So let's look at the one that got 5 times bigger. So this scale factor was 5. The perimeter got 5 times bigger. 12 to 60 is 5 times bigger. The area did not get 5 times bigger. It got a lot of times bigger. I wonder how much. Now think about it. The area scale factor was 4 when it was 2. It was 9 when it was 3. So if this one was 5, guess how many times bigger it got for this one? So the area scale factor for this one is 25. It got 25 times bigger. It went from 8 all the way to 200. And 8 times 25 is 200. So something to realize is the perimeter, it is in regular units like the side links. Therefore, it's going to be the same. The area is in a different units. Okay, so your area ratio is always going to be whatever the scale factor is. If the scale factor is 1 to 2, or say 2 times bigger, then your area scale factor is going to be 2 squared times bigger. because that's what happened every time right here. If our scale factor is 4, guess what our area scale factor is going to be? It's going to be 4 squared. Just like up here when our scale factor was 3. So if our scale factor is 3, then the area scale factor is going to be 3 squared. Okay, because we're in squared units. So some things to kind of, you know, just always remember is that if you have in just general, so let me go back and write it kind of at the bottom over here. In general, if your scale factor is x, then your area scale factor, sorry, this pen is not working good right now. Is going to be x squared. Okay. All right, or you can write the ratio. If the ratio is from A to B, then your area ratio is going to be A squared to B squared. Okay. All right, so let's take a look at some problems on how we need to make sure we use that whenever we're working with side links or area of similar figures. So in this first one up here, problem number 1, it says if the area of a triangle is 37 square centimeters, what is the area of a similar triangle that has been dilated by a scale factor of 6? So we got 6 times bigger, so something to think about. So this area is 37, and imagine a much larger one. We're looking for the area of this one. Well, all of the sides got 6 times bigger, so our scale factor is 6. Please do not multiply this 37 times 6 and get this to be our answer, okay? Because it's a different units. Just because the sides got 6 times bigger, the area is not going to get 6 times bigger. It's going to get 6 squared times bigger. So to get this answer, you want to multiply it by 6 squared, okay, which is going to be a really large number. So let me get my calculator. 37 times 6 squared, which is 36. The new area for this one is going to be 1,332 centimeters squared. Okay, so we had to multiply it by 6 squared. Let's look at this one on the bottom. It says the area of a kite is 56 square inches, and one of the sides is 20 inches. What is the corresponding side length of a smaller kite if the area has been quartered? So the area has been quartered. That means it's been 1/4 the size. Okay, so we have I guess a somewhat larger kite, and this area is 56 square inches. We'll say one of the sides is 20. We'll just mark it there. And then now we have a much smaller kite. In fact, 1/4 the size. It's asking what is the side length. Okay, I guess we don't need to find the area, but the area has been quartered. If you wanted to find the area to get that, you would go 1/4 the size. So what is 56 divided by 4? 14. So this area, and we didn't have to find that, but just there it is. And so the side length that corresponds to this 20 is the one we need to find. Well, just because the area's got 1/4 the size, a lot of people might think, oh, it's 5. No, it's not, because we're in different units. Okay, so if this got 1/4 the size, what do you think you need to do in order to now figure out the side lengths? Think about if I squared it to get my area ratio or area scale factor, what do you think you need to do to go backwards if you're working with the area? You want to square root that, okay? So this area was 1 to 4. you want to square root both of those. And so square root of 1 is 1, and the square root of 4 is 2. So then that means it's not going to be 5, okay? So big no-no. This is going to be 10. So 10, what are we at? Inches. That's the answer right there. So you need to remember this right here. All right, let's try one more. The area of a trapezoid is 48 square centimeters, and the area of a similar trapezoid is 432 centimeters squared. What is the height of a smaller trapezoid if the height of the larger one is 24? All right, let's draw this out. So we've got a small trapezoid and a big trapezoid. This area over here is 48 square centimeters, and this area over here is 432. And it says the height of the larger one. So this height is 24. Question is, what is this height? Okay, so here's what a lot of people would do. They would do probably a proportion like this, and it's incorrect. They'll say 48 is to 432 as x is to 24. Now we cannot compare these. These are in squared units over here on this side. This is in regular units, so you cannot compare these measures. So what do we have to do to these numbers to get the correct ratio? This right here, to figure out this scale factor, you can divide that. So let's see, does 432 divided by 48 come out nice and even? It does. So when you look at this scale factor right here, it's 9. The area scale factor got 9 times bigger. So what do you think the sides are going to be? Your scale factor for the sides and all its parts is going to be the square root of 9, which is 3. Okay, so I'm going to put a big red X through this. Don't do that. Okay, that is wrong. So what you can do is just see, oh, well, if that got 3 times bigger, that's, you can just take 24 and divide by 3. So this height right here, so that height that they are asking us to find is going to be 8. All right, and that's it. Those are 3 problem examples.